Hey everybody, this is Mike Bartles from HEC. Within this presentation, I'm going to talk about the pilot studies that are being used to develop the standard operating procedures that describe how FFRD applications should be performed. This video is part 3 within a series of videos devoted to the FFRD topic. Within this video, first I'll provide an overview of all the pilot studies that are being undertaken as part of the FFRD initiative. Then I'll go into more detail with regards to the Duwamish River pilot study in particular. Now, like last time, if you know which dam this is, please write it in the comments. The FFRD program is being executed at the 4-digit Hydrologic Unit Code, or HUC, watershed level based on the watershed boundary dataset as the standard study unit. The average HUC 4 size is about 15,000 square miles, while the average HUC 8 size is about 1,500 square miles. HUC 4 basin modeling includes smaller areas for hydraulic models, which are usually approximately like the HUC 8 level. To develop FFRD simulation tools and procedures, we are completing 3 pilot studies. The first pilot was completed within the Kanawha River watershed in West Virginia. The second pilot was completed within the Duwamish River watershed in Washington. And the third pilot study, which is still in progress, is taking place within the Trinity River watershed in Texas. Once we're done with these pilots, we'll have a set of standard operating procedures that can be utilized throughout CONUS. Now I'll talk about the Duwamish River watershed pilot study to give you an example of all the interactive components that go into an FFRD implementation. First and foremost, credit should be given to the large team of USACE personnel that contributed to this effort. The list shown here isn't complete as there were numerous others that made significant contributions as well. The Duwamish River is the name of the lower 12 miles of the Green River, which begins in the mountains southeast of Seattle and empties into the Puget Sound. Altogether, the Duwamish and Green River span about 70 miles in length with a watershed size of approximately 500 square miles. The terrain within the watershed is very mountainous in the upper part, with some peaks exceeding 5,000 feet in elevation. In the lower part of the watershed, slopes mellow out quite a bit. Now, snow accumulation and melt is also an important source of runoff within this watershed. Howard Hansen Dam is located within the upper part of the Green River watershed. It is owned and operated by the Seattle District Corps of Engineers and has an upstream drainage area of approximately 221 square miles. Its authorized purposes are flood risk management, low flow augmentation, and municipal and industrial water supply. The Howard Hansen Dam provides huge amounts of flood risk management benefits in the lower Green River Valley. It's estimated that over 200,000 people and $25 billion in infrastructure are located downstream of Howard Hansen Dam along the Green and Duwamish rivers. During the January 2009 flood event, it's estimated that over $3.9 billion in flood damages were prevented by the dam. That's staggering. An HEC HMS model was constructed for the entire Duwamish River watershed. To reiterate past topics, the purposes of this model was to compute runoff hydrographs for the reservoir model to consume, compute excess precipitation in gridded format and baseflow time series for the hydraulic models to consume, provide a distribution of reasonable starting states for every day of the year across the entire historic period of record to support epistemic uncertainty estimation, and accurately simulate the precipitation runoff response of stochastic storms transposed throughout the watershed within a reasonable amount of computational time. The animation on the left shows the simulated accumulation and melt of snow for a historic event, while the image on the right shows the computed runoff in blue compared against observed runoff in black. An HEC ResSim project was constructed for the Duwamish River watershed as well. The purposes of this model was to simulate operations at Howard Hansen Dam and compute reservoir releases for the hydraulic model to consume. The image on the left shows the watershed that was included, while the image on the right shows the computed reservoir operations for Howard Hansen Dam for a historic event. A single HEC RAS project was used to compute hydraulic variables of interest. As was previously mentioned, the entire Duwamish River watershed was included, and 2D computations were used everywhere. The hydraulic modeler attempted to strike a balance between accuracy and run times. In short, including more detail requires longer compute times. This isn't a problem when only 1 or 2 simulations are required, but if you remember, we need upwards of 1 million to adequately describe risk within this watershed and provide the necessary outputs for FFRD. That being said, 2D mesh resolution was added at locations that warranted additional detail, like those within the heavily populated lower Green River Valley. While only 1 major dam is located within the Duwamish River watershed, there are over 10 levee systems of significant size. Each of these levees were included within the hydraulic model as well, and allowed to breach. Also, Howard Hansen Dam was allowed to breach if the sampled conditions within the stochastic simulations were significant enough. Now, in this video, I provided an overview of the 3 FFRD pilot studies that are being used to develop standard operating procedures for model construction and simulation. I also talked about the various models that are being used for the Duwamish River pilot study. In subsequent videos, I'll go into more detail with regards to the Duwamish River pilot study and provide lots of outputs. Thanks for watching. I'll see you in the next one.